Hi, math lovers. Welcome to notes number 39, second day of lesson 2.1. I'm going to do a word problem with you today from your textbook. It's a college problem. We're in the book on page 182. It says, or number 129, it says the Penn State University had enrollments of 40,571 students in 2000 and 44,112 students in 2008 at its main campus in University Park, Pennsylvania. Assuming the enrollment growth is linear, find the linear model that corresponds in terms of the letter year t, where t is equal to 0, corresponding with 2000. Use your model from part A to predict the enrollments of 2010 and 2015. And part C says, what's the slope of your model? Explain the meaning in the context of the situation. Okay, so a couple things going on here. I'm going to do this old school by hand, and then we're going to pull out our handy dandy calculators. The first thing we need to think about with this question is it gives me some direction about my year. It's telling me that 2000, the year would be t is 0. So here we're going to use the ordered pair 0, comma, 40,571. I'm not going to put the comma in the 40,000 because it looks weird with the ordered pair. And then the 2008, that would be 8 years after 2000. So 44,112. Okay, so I have two ordered pairs, and now my job is to make an equation. You guys remember how to do these problems. So first thing I'm thinking about maybe is my slope, okay? So my slope is equal to y2 minus y1 over x2 minus x1. So we just plug these values right on in. So let's see, 44,112 minus 40,571 over 8 minus 0. So that is 3,541 over 8. All right, so now I have my slope. I'm going to choose to use point slope because I have a point and I have the slope. So always write down your formula so your reader can follow you. Okay? So let's use the point up here because 0 is so much fun to work with. Y minus 40,571 equals, I'm going to use the slope I just figured out, 3,541 over 8 times x minus 0. Oh, that's so nice, isn't it? So y equals, let's see, that'd be 3,541 over 8x plus 40571. Okay. We have found the equation of the line, okay? Now, part B says, use your model to predict enrollments from 2010 to 2015. Now, as your future statistics teacher, I'm going to tell you to proceed with caution. Do not extrapolate outside the data set. They are asking you to extrapolate outside the data set, okay? Not a good thing to do. So they want you to figure out 2010. So we're going to let t equal 10, and they want us to figure out 2015, so t equals 15. We will proceed with caution because this is what Ron is asking us to do. If in my statistics class I asked you to do this, you would tell me you do not extrapolate outside the data set. There could be so many other confounding variables, so many other things that could change the enrollment at Penn State University. Okay, so you're going to pop all this into your calculator, and what you're going to end up with is 44,997 and then 47,210. Okay, so we answered the question that Ron asked you. The last thing they want to know is about the slope. What does the slope mean? Well, the slope means that we're going to increase this much, right, of a population per year. I don't have that exact number. Let me grab my handy dandy. Clear. So 3,541 divided by 8. So that's approximately 442. So for every year that goes up after 2000, we're going to increase our enrollment by 442 students. Okay. Things are going to change. Lots of things could happen. A pandemic could happen. There could be a campus scandal. And people might not want to go to Penn State anymore. Tuition could go sky high. Lots and lots of confounding variables here. Okay. The second thing I wanted to show you is how to do this on your graphing calculator. All right. So this is old school by hand. This is the way Beth Glennon likes to see it. Okay. But if you have your TI-84, what you're going to do is make sure to tilt it. We're going to use these same two ordered pairs that I had here. So let's go to your stat menu, and you're going to, all right, I had some data here stored, so I'm going to clear it. I just go up to list one and I hit the button clear. Do not hit delete. If you hit delete, it will delete it. We want to clear it, so we clear it. Okay. So my two ordered pairs I'm using are 0 and 8. And then I'm going to put in my Y value, which was 40571. And my second ordered pair, which is 44,112. Okay. So there are my data points. Now, I've entered them in the stat menu. Notice I went stat and then I went to edit. Now I want to do something with that data. I'm going to calculate the data. So I go down here to linear regression. Now notice in your graphing calculators, there are two linear regressions. There's one that's AX plus B, and there's one that's A plus BX. I don't care which one you use. It doesn't matter. It's just going to switch which one is the slope and which one is the y-intercept. Now we're going to tell the calculator, we're going to use list 1 for our x, list 2 for our y. We're going to clear this frequency list, which should not be there. And I want to calculate. All right. So look what we just did. Look what we just came out with. We came up with the same y-intercept on our calculator. We came up with the same slope, this 442.57. Isn't that fabulous? That's really nice. Okay. The last problem I want to do with you, not a calculator question, put this away. The last one I want to show you is number 99 from the textbook. So another textbook question. If I can find it here. Okay. In number 99, they're giving you this formula here. They're saying a over x plus b over y over b equals 1. That's what's called intercept form. It's not very common. But that formula is telling you A is going to be the x-intercept and B is going to be the y-intercept. So they give you the ordered pairs there. So they want us, in number 99, they want us to come up with an equation for our line. Let me write down the formula. A over x over A plus y over B equals 1. Okay. Where our x-intercepts are going to be A0 and B0. Okay. So in this question, they're saying, what's the equation of the line? What's the equation of the line? Which have the points -1, 6, 0 and 0, -2/3. Now, I picked this one because this isn't one that you're probably just going to go ahead and graph and then count your rise over run because you've got the fractions here. All right, so let's go ahead and plug our values in. X over -1/6 plus y over -2/3 equals 1. Oh my gosh, we're almost done. This is kind of a mess. You have lots of different options, but I'm personally going to think about this first, and then I'm going to think about that. So let me think. I've got x divided by 1/6, right? Plus y divided by -2/3 equals 1. That's what's going through my head. You might have something else going through your head. That's okay. That's what makes this world go round, right? Oh, I lost a negative sign. Oh, be careful, kids. That's so easy to do. 6 over -1. Dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to go ahead and I'm going to take the reciprocal here. All right, so over here I'm going to have -6x plus -3/2 y equals 1. It looks like we have our form. Look at that. Now they ask in the equation for beautiful standard form to make it pretty, to get rid of the fractions. So in standard form, you want this coefficient here to be positive. So if I multiply by a -2, so I would have 12x plus 3y equals -2, and that would be the equation. Okay? 2 problems today, 2 application questions. Have fun with your problem set.